The final demonstration for the day will be given by Dr. Daniel Morozov, co-founder and CTO, and Connor O'Day, the head of business development from VIDROVR Incorporated. The topic of their demonstration is large-scale computer vision systems for visual intelligence. The company will have 20 minutes to demonstrate their technology, followed by a 10-minute Q&A session. And when you're ready to begin, we'll start the clock.
Thank you. Can you guys hear me? Perfect. I'm Dan, this is Connor, and we're going to talk to you about VIDROVR today. So we're a Columbia University spin-out. We spun out about 3.5 years ago and been working in the private sector and been recently engaged by various aspects of DoD and public sector. And what we effectively focus on is this problem of basically understanding the world's large-scale video production and making it more interpretable and processable. So we try to solve the problem of missing visual intelligence. So if you remember anything from my talk, I want you guys to remember this, that multimodal video understanding is going to change the future for the warfighter, and it's going to make it a more effective process for them. And what I'm going to go through in this presentation are going to be 3 facts that we've engaged in. Effectively, we've worked in PAI, which stands for publicly available information, FMV, which is full motion video, and finally kind of the new area we've been working in, which is human-machine teaming. And we effectively touch on a number of AI, ML areas in what the Army and a number of other people in the DoD are interested in. So the first section is PAI. Radicalization and disinformation campaigns are top of mind these days. They're in the news effectively. These are pulled directly from social media today. They insinuate attacks and all sorts of other things. This is what usually video metadata looks like online. And we take it a step further and we basically build a slew of different machine learning and computer vision pipelines to make this more interpretable. So we do everything from facial recognition all the way down to like large-scale video classification, building both frame-based and video-based models, as well as things that no one else does in the business. This is how we stack up against the big players in the space, Google, Microsoft, and Amazon. We hold our own. 5 is the top, 1 is the worst, and we're pretty good and solid and have pretty large coverage in terms of what we do. This is a third-party test by a large company in the space. We also do things that no one else does. In other words, we do matching and lookups on similar visual intelligence systems. So in other words, if you want to find partial matches in images from either PAI or FMV, we do that as well. We also do large-scale social media embeddings and things like that. We also build always learning knowledge systems. In other words, systems that learn as they visually process information without actually being cued by the user. So as our system processes more information, it learns new things. And I'm going to show you some examples of this, followed by a final demo with Connor, which is streaming live right now. So effectively, we're funded by the National Science Foundation and some other folks for doing what are called visual knowledge graphs. And so we effectively take video and break it into its individual component parts and then fuse them together in a knowledge understanding system. This is basically an outline of what you can do with it. And I'm going to show you an exact example of what this looks like for an intelligence use case. So effectively, if you find text mentioning Rusal, which is an aluminum company out of Russia, you're able then to link that to facial recognition information on Oleg Deripaska, and then understand that the Kentucky mill that's being referenced in this document is actually referring to Brady Industries, which is affiliated to the governor of Kentucky. And so you can learn these implicit relationships between people by mining this information in this multimodal sense. This is an example of a search system built across a month's worth of content. You type in North Korea, there's no human in the loop here. This is directly pulled from the internet. We automatically pull down videos that are relevant, but we also have a knowledge graph that allows us to infer relevant people here. And so now we can recommend certain aspects of that video, like 40 seconds in here, where Kim Jong-un is actually appearing and talking on screen. We similarly learn visual classifiers. So in other words, what is relevant to the query of North Korea? In this case, ballistic missiles are relevant. And so our system automatically learns what they look like and then allows you to pull them out directly out of the feed. And so these are ballistic missile launches directly from the video. This is about a month's worth of video content that we're running on the fly. This is PAI applied to radicalization content directly appearing on Instagram, where we weren't given any training data. and effectively are able to cold start our models to basically pick up radicalized content and then link back directly to Instagram on the fly. What you're seeing here is the link back to the original source, as well as the account and any other information we're able to pull down. Excuse me. This will show you the actual video that was triggered. And it's going to jump into an example of the models and how we are able to build them. I'm actually going to hold off on that and show you this in real time live. So what I want to jump into now is actually giving you an example of what a real-world analyst at the State Department uses this for. We were processing broadcast feeds coming off of CGTN, which is the Chinese broadcast network, and some of the data that we're able to pull off and create multimodal alert systems from this. So these are some alerts that were designed based on the interests. Tags or visual tags, spoken words, and effectively custom detectors, which are these custom classifiers. And on your right, you'll see the ingest sources that we're using. So everything Facebook, Instagram, YouTube, and public stream broadcast. This is what a creation of an alert looks like in our system. Effectively, you just type something in. This is just an example video. And as you create your own custom alert, our system basically will collect data and information that's relevant to what you've put in. So if you want to detect me, you just type in my name, and you label it as person. If you want to detect a tag, you can type in the stage or something along those lines. And then when you hit create alert at the end of this, you'll basically be able to automatically start our video processing system looking for that information. And you'll see that in real time right now from what Connor's streaming live. This is what our system is able to pull out after a month's worth of video content. And this is directly like information that was provided to the analysts. Everything from things around white papers, which is a weird thing that you might think is noise, to the Straits of Taiwan and etc. But when you actually start looking at the data, you actually realize that this notion of white paper is highly relevant to this topic. And I'll just read this out for you so you have an idea of what this is saying. The white paper stressed that the PLA will resolutely defeat anyone attempting to separate Taiwan from China and safeguard national unity at all times. Right. Similarly, we have the custom classifiers firing for Chinese warships. That was one portion of interest that we had no training data for. This is what alerts look like once they're in the system, just a sample of alerts that we're able to pull down. And I'll show you some examples of these in the real live feed. This is another alert for military things. So these are our current engagements. We have engagements with the State Department, the Air Force. We're down selected for the Semaphore program out of DARPA. And we have some current engagements with both the private sector, where we're a performer on a 5-year FAR, as well as the more kind of media-focused sector that we've been serving since the beginning of the company. Now I'm going to jump into understanding FMV, and as long as you guys are bearing with me, I will show you kind of what other applications for visual knowledge graphs are available out there. This is effectively a pose estimation system running directly from a phone in theater. Now, if you take this and take it one step further, you'll be able to see how we construct full motion video in relationships to knowledge graph. So not only do we understand that there's a person detected, we're able to classify whether or not it's a fighter, and then extract and then crop to run a separate classifier on whether or not they're armed and what they're wearing. And this is all being done in real time. This is being run on a full motion video capture off a CCTV camera. And the way you can think of it is basically we're building like a cubist representation of a holistic person moving through a video scene. And we are building this over time. So there are a number of machine learning models running in the background trying to make sense of this information. This isn't obviously only applicable to people. This could be applicable to other things as well. And I'm going to show you an example of that right now. This is actually drone footage captured from Turkish drone flying over Syria, available directly from YouTube. And the problem here that a lot of analysts face in this space is re-IDing objects or things in the feeds over time or as different platforms come on station. And we're showing how we're actually able to do that through the time of this video. And as you can see, this is like a video that's sped up because the drone's flying over. And there are a number of different angles that are being shot here. So current engagements, again, in the FMV space are diverse. We have engagements with DSIGs. We have some engagements with the Army and some private intel stuff that we're working on, as well as like private medical corporations that are doing totally civilian kind of tasks of understanding where people are in a hospital and a facility where they're getting dialysis or something along those lines. Obviously, for drone FMVs, we don't have any private. The final thing I want to touch on before we jump into the live demo is human-machine teaming. So we're applying for kind of the Army resupply mission of how do we take our computer vision systems and now have them act on the world. So now what we're able to do is we're able to actually plug into robotic platforms and have those robotic platforms perform tasks based on the interpretation of what this real-world computer vision system can do in real time. And the idea here is basically very simple. In this case, we just use a robotic platform to carry around to a howitzer. That's all it's doing. But the ability of streaming video live and issuing orders from a live feed becomes kind of this ability for an operator to team with the actual robotic platform that's deployed in the field. And effectively, this mirrors very similarly what we're doing with our knowledge graph systems today. Obviously, there's a lot of science that goes behind this. We have a number of publications and patents that you guys can check out. They're available online, and since we're formally academics, they're all obviously available. In the 6 months that we've been doing this, we've already been granted another patent. So when we first started, we only had one, and now we have a second one in the pipeline. So that being said, what I want to do now is show you kind of what's going on. So this is Connor streaming live over the internet off of that GoPro. This is not pre-recorded. This is actually being done right now. And I'm going to show you that we're able to actually plug into this platform directly in real time and process this information. So this is literally me speaking on stage right now. This is all video that's being done. And what I'm going to show you, which is a little bit more interesting, is we did a little walkthrough on the floor. And we're going to show you what we're able to pull out by just walking through on the floor and streaming this data to our platform in real time. So just to level set here, we built a detector this morning to detect things like pistols, rifles, tanks, things like that at very high accuracy. We didn't have any training data for this. And so our system builds some generative capabilities. We have generative models running in the background to actually make this possible. We've generated baseline performances. These are validation metrics on precision. So we're able to, say, identify tanks at 86% accuracy, right? And now all you do is you pick the ones you want, you hit like activate, and now we're looking for these things in our feed. I'm going to jump in to show you what that looks like. So this is raw feed directly on, like oh, this is not good. Let's try this again. Murphy's Law. All right. So this is live feed coming on the bottom floor. That's why we have some spotty internet connection here, because we're streaming live. But what I want to show you effectively is that now we're able to pull down tanks. Right? I just clicked on tank, and that's the high precision detector from a booth downstairs. Right? Similarly, we pull down faces. This is pretty easy. That's that woman right there. And again, if we want to filter for high confidence detections, we can do the same thing here and pull down vehicles. So you can see a car appearing in the feed as well. Obviously, this feeds into our overall search and retrieval systems that we can search and retrieve against, and a slew of other models like scene recognition models, activity recognition models, on-screen text, and speech-to-text models. So we're able to understand what's going on. And this scales with any operator in the field, because this is running on a huge server somewhere, right? And so what we've been working on is effectively getting this to the point where we can actually have this scalably deployed and running in real time, and I think we're getting there. We already have systems running in place that are processing thousands of hours for our customers in real time. I think that's all I wanted to show you guys. Would love to answer any questions or anything like that. Oh, and one thing, if you guys want to get in touch, just I'll throw my email out here. Feel free to email this address or see us at the booth tomorrow. We're going to be streaming live. Cool.
The number of sensory inputs. Right now you've got one camera, one walkthrough, one processing. How many simultaneous, is there a limit for how many feeds you could put into your engine?
So Yeah, it scales linearly with a cluster. So right now, our cluster can do on the order of about 5,000 hours of video per month. We can just make more machines, and they'll just do more. So, I mean, 24 hours per stream, and then you can multiply that how many people you have running.
How long does it take you to build a picture of something? Say you want to track something, you're collecting full motion video, you've got these things. How long does it take you to put together a full Intel picture?
So, are you asking about the model, or are you asking about?
So you've collected information, facial
Yeah.
person. You may have seen some video, and you begin crosswalking certain
Yep.
video images. How long does it take you to put together an Intel picture that this is a person or a thing or something I want to monitor over time?
So honestly, as soon as it's done processing, so an hour of video processed in about 10 minutes in our system. So we're faster than real time end to end. Any submodels are running faster than that. So if you need a subsection of things running, like just your facial recognition systems, you can do that faster. Effectively, the Intel picture really depends on what you're trying to look for, and yeah, but it's already indexed at 10 minutes, so you can search for it.
So, hypothetically,
Yep.
right? So you're surveying a scene out there, and we come to learn that every brown thing that looked like a rock is really an IED, and now you know what it looks like. Could you then go back and say where all those were, or did you have to know about that beforehand?
No, so we can go back. So any video that's processed in the system is stored unless our customer decides they want to delete it, and we can rerun it through our system at any time.
So one of the problems we run into in doing image classification for for the military use is that some of the things we really, really care about, we don't see very often.
Absolutely.
Can you just talk about how you might address the challenge?
Yeah. I mean, realistically, the questions of like, if you don't have enough data available, there's only so many things we can do, right? So things we can do is we basically build generative models to circumvent that and grow the data set representation. We do domain adaptation to basically understand whether or not we can parlay other information. So this is very common, say, going from visible spectrum to IR, being able to transfer learn, things like that. I mean, we're limited, obviously, by the data that we have. But beyond that, we try to get high performance out of, we have few-shot learning techniques. That's how these custom classifiers work. So we effectively only need tens of images to reach asymptotic performance against standard classification for small class number sizes. Yeah.
Do you need internet access for this to pull this information, or you can have it stored on personal device?
Currently it's running on the internet. It can run on a personal device. This is fully deployable on, it's a Dockerized system that's fully deployable on a Kubernetes cluster. So if you guys have a pallet, like a crate or something like that with the right hardware and bare metal, we can ship it.
How large of a device?
Let's see. This thing for 5,000 hours is running 3 GPU machines and 1 standard machine. So like, blade-wise, it's like a standard crate. It's not going to be bigger than that.
You're showing recorded videos, though. Would it highlight something in actual live feed?
Again,
So if I was recording, if I was a team on mission and I was recording and I was pushing that back to personnel on the ground, could they relay back to me that something was seen on the ground?
yeah, so that's the idea, right? So effectively,
Right.
if you're within that 10-minute mark and you're running all these models, yeah, obviously. If you need some subsection, it can be real time, like real time. In other words, like 60 frames a second, right? So like it really depends on kind of what the mission spec is, and kind of the idea of this demo is to basically take the notion of ATAC and plug it into a visual space, and then you pick out your kit before you go out.
Absolutely.
So I'm going to date myself, okay, for a second. Used to be to recognize somebody, it was so many pixels between the eyes for facial recognition, okay? I won't say what that is, and it was always, determined upon your, the magnification, your field of view and all that. Can you kind of address those types of things in terms of detection?
Yeah, absolutely. It's a good question. So effectively, it really depends on what the model that's deployed is trained on, right? What you're doing here is like faces in the wild on basically with this aperture at a certain distance. So effectively, you want to cover a certain range. of like sizes of a face. That model is pretty much trainable today in like out-of-the-box systems, and you'll be able to get very high performance on the detection itself. And then the recognition portion is obviously the quality of the data that you built the model with. So if you have, like if you've been following the news, a lot of companies out of China and things like that have huge data sets that they filtered and clean, and so they can get very high accurate representations of faces and be able to determine different ones along those lines. That's usually determined by the quality of the initial data you're training on. But I mean, we're running some state-of-the-art models here that really perform high-quality classification.
Along those lines, I was going to ask about a little bit about resolution. But I noticed that you were able to kind of set the accuracy level. So can you speak to like false alarm rate versus the probability of an actual hit?
Right. So I mean, that depends obviously on the model,
Sure.
And across the board, these models range. I can send you the numbers afterwards. They're exactly the numbers. I don't remember off the top of my head. But for example, our face recognition system here. Let me actually show you the numbers here that were reported. This is a third-party test on a held-out data set, right? So we have 63% on the first set. We have a 63% precision with 12% recall, 100% precision and a 30% recall. Again, these are third-party data sets. I've never seen what they actually even compared to, but they did like 1,000 faces here. And these are like relatively famous, maybe like not so famous people. So that's how they're quantified. We try to stay in the 80 to 90% range for across our models. Yeah.
And you're using open sources, so you aggregate a lot of information that's kind of in your system. If you're using, say, like a Google model, can you protect against Google being able to access all this information you've kind of aggregated together in your proprietary format and pulling that for their?
So all the models we have displayed here are trained in-house.
Okay.
So everything we're doing here is basically in-house models, and the data that we've aggregated is in-house. We never share our customers' data with anyone. So effectively, if Google has our data, they've hacked our system, which probably is not what they want to do anyway. But yeah.
You mentioned some of the organizations that you've worked with. I was just wondering, because of the AI and machine learning part that you've talked about, have you contacted the AI task force at Carnegie Mellon, the Army's entity that's trying to look at the big problem?
We have not. We've spoken to the out of the Army. We've spoken to like the Jake, and we've had engagements with more Air Force side as well as RDEC at Picatinny.
Okay.
All right. Thank you very much.